I'm going to go through the AQA Mathematics Unit 1 paper from the 30th of June 2011. It's an hour-long paper. I hope to give you the marks or the correct answers and an explanation of how they were arrived at in the space of about 15 minutes. Okay, let's move to the first set of questions. Okay, now it's all about Matthew recording these birds, and he's done a tally for them. It says in subpart 1, part A of question 1, complete the table. So all we do is count up the tallies. So there's 4 there, there's 3 there. Now here, each group of 4 with a bar across represents 5s. So we've got 5, 10, and another 2, 12. Here we've got a bar and 4, so that's 5 plus 4, 9. Then we add them all up, 7, 19, 28. Now, what fraction of the birds are robins? There were 4 robins out of a total of 28 birds. So the fraction is 4 out of 28. But it also says give your answer in its simplest form. Now it's a calculator paper. So we type in 4 over 28. In the newer calculators, the fraction button will look like there's 2 rectangles separated by a line, and also on the display it'll have 4 over 28. Then press execute and there's the answer. 1/7. And for all that you get 3 for turning the tallies into numbers and 2 for putting the fraction in its simplest form. Now Leah recording the birds that land in the garden. There are 4 robins and so forth. She has finished the first row of a pictogram to show the results. Complete the key. Well, she's used 2 of these symbols to represent 4. So if 2 represents 4, then 1 must represent just 2. And now we're going to fill in the rest of the pictogram. Blackbirds. There were 6 of those. So each of these symbols, remember, represents 2. So we put 3 there. But what about the 5? Well, the first 2 that landed is easy. But what about for one bird? Well, we draw half a picture. And a similar thing for the sparrows. That's the first 2 that landed, and then a half one. And for all of that, you gain 4 marks. Right, 500,000 people record the types of birds in their gardens. In total, they record 8 million birds. On average, how many birds does each person represent? How many birds, does each person record? Birds, person. The order of the question tells us the order of our calculation. So there were 8 million, it's 8 with 6 zeros, birds, 500,000 people. So let's get our calculator to do that. 8, 1, 2, 3, 4, 5, 6 over 5 and what's that, 5 zeros? To give us 16. The answer is 16. Make sure you show your working. I'll just pause. I'll go back to the working. Yeah, if we'd have written down an incorrect answer, let's say some brainwave got us to write down 26 and there was no working, then we would have got nothing. But even if we wrote down 26 and clearly showed this, then we get at least 1 mark for working. Here are a list of the birds at a bird table. One bird flies away, another bird arrives at the bird table. The new mode is robin. Well, at the moment there are just 3 robins and there are 1, 2, 3, 4 blackbirds. So at the moment the mode are blackbirds. It says the new mode is robin. Well, obviously we've got to have a robin here arrive at the bird table. But if a robin, for instance, replaced the starling, we wouldn't have robins as mode because we'd have 4 robins and 4 blackbirds. So this helps us answer the second part. Which bird flies away? It had to be a blackbird. And which bird arrived? It had to be a robin. For 2 marks. Right. Now, Ella has these coins, Jaden has these. Ella gives Jaden 1 coin, they now have the same amount of money as each other. Which coin does Ella give to Jaden? The first thing you should do is add up the value of the money. 70, 80, 90. Ella has 92 pence, Jaden has 72 pence. So at the moment, the difference is 20 pence. Now how can with 1 coin we cut that difference in half? Well, by giving away a 10 pence. That would bring Ella down to 82 pence and Jaden up to 82 pence. So which coin does Ella give to Jaden? The answer is a 10 pence coin for 2 marks. Callum has asked some boys and girls to choose their favourite fruit. Drawing a dual bar chart, so it's 2 bars adjacent to each other, showing the choices of, in this instance, boys and girls. How many more boys? More. Very important word. We could lose 2 marks here. 8 boys chose grapes. 3 girls chose grapes. But the question was about how many more. So we have to take the smaller away from the larger to give us 5. I bet quite a few people across the country put down 8 as the answer, the number of boys. No, it was how many more. How many boys does Callum ask altogether? Well, to answer that, we've got to see how many were in each column. There was 8 that liked grapes as their favourite fruit, 4 bananas, 5 apples, and 3 orange. Add them up, 17, 20. So there were 20. Now, this is quite a pivotal question, because if we didn't get this right, this next bit's going to be very difficult. Callum asked the same number of boys and girls. 2 girls chose apples. So we know that 2 girls chose apples. We know that the total is 20. We also know from earlier that 3 chose grapes. Twice as many chose bananas. I'll call them bans as oranges. Now, we know how 5 chose out of the 20, so we've got 15 left. How can we organise it so that twice as many chose bananas as orange? Well, the only way is if 10 chose bananas and 5 oranges. And now we complete our charts. So 2 chose bananas, told that. I just got that wrong. No, it was 2 chose apples, sorry. We just worked out, didn't we, that 10 chose oranges. Bananas, sorry. Been a hard day. And 5 chose oranges. And for that we get 3 marks. Can you see though, if we didn't get that 20 here, we'd have had a great difficulty in getting the 3 there. Right, halfway through. Now, a student from year 10 is chosen at random. Mark with the letter the possibilities of each of the following on the scale below. The student walks to school. That's been done for us. It's a quarter. What's the probability does not walk to school? Well, there's our quarter. So this, the rest of the circle, the pie, are all those that did not walk. So that's 3/4, which must be here. Now, the student travels by train. None of them, if we look, travel by train. So for C, we put our arrow here clearly above that. Not likely, impossible. 40 students travel to school by car. How many year 10 students are there? So here we go. Now, to get this done, we've got to, I'm just going to have to change from full screen view, we've got to measure that angle. So I'll just get my protractor. Let's go back to full screen. And first, I center the protractor on the center of the pie. I then spin it so that one of these lines here reads 0. Now I'm going to read the outer scale, and if I look, 60 degrees is the size of that angle. So let's have a look. 60 degrees represents 40 students. We want to know how much 360 degrees represents. Well, the way to do that is this. Here's the bit of information directly concerned with what we're trying to find. So we make that the top of our fraction. What's the other bit of information with the same units? It's 60. And then what bit of information haven't we used? We haven't used this 40. So we do 360 over 60. 360 over 60 times 40 to give us 240. Does that seem right? It does. Right, Danny and Ed are in the same quiz team, and each round a person can score up to 10 points. Here are their scores. The scores for Ed have a range of 3 and a mean of 5. Compare the scores. Well, the first thing we should do is to find the range for Eddie. The range for Danny, my mistake. And to do that, we subtract the smallest from the largest score to give 10 take away 1 equal to 9. There's her range. What about her mean? Well, to do that, we add them all up. 2, 12, 14, 22, sorry, 14 and 10 is 24, 25, 28. So mean, Danny, equals 28. How many scores were there? There was 7. So it's 28 over 7 equal to 4. Now, compare the scores. Well, let's look at the range. Danny's range is far greater than Eddie's. So what does that mean? Well, Danny is more inconsistent. If your range is greater, then you are more inconsistent than Ed. That's our statement. Now we back up with the evidence. Range of 9. I've included the measure I'm using compared to 3. Now, what's the second thing we're given? The mean. The mean for Ed is 5, that for Danny is 4. So on average, there's that little phrase we use, Ed scores higher. And now the evidence, including the measure we used, the mean of 5 compared to 4. And for that, there's a lovely group of 5 marks. Now this next one is only worth a mark, but you have to think about it more perhaps than the other one. In the final round, only one person can play. The team needs 9 points to win. Who would you choose, Danny or Ed? Give a reason for your answer. Let's think about this data for Ed. He's got a mean of 5, but his range is 3. So as like the other scores are, well, the smallest one and highest one, 3 and 6. It's very unlikely that the range is 4 and 7 with a mean of 5. Sorry, that the smallest is 4 and the highest 7 when there's a range of 3 and a mean of 5. They're all going to be around about and close to that 5. We need 10 to win. So who would you go for? Well, the answer is you'd go for Danny, because she is more likely to get 10. She's also more likely to get a low score, but needing 9 or more to win, we need to go and take that gamble. So it's going to be Danny, and because she's the one that scores the really high scores, or as we've seen, the really low ones. Right, not many more to do. A bag only contains red and blue counters. It contains 24 red counters. A counter is chosen at random from the bag. The probability of choosing a blue counter is a quarter. So probability blue equals a quarter. There's only blue and red, so we can work out the probability of a red equals 3/4. Now, we're trying to find out what 4/4 is. The whole. And the way to do this is, as I mentioned with one of the earlier questions, this is the key bit of information. The number of quarters. Where's the other bit that's similar to it? It's that. And we know that 3/4 is 24. So we multiply 4/3 times that 24. Just get a calculator to do that. 4/3 times 24. So the answer is 32. Is there another way of answering that question? Well, yeah. If 3/4, you could do it this way. If 3/4 equals 24, then 1/4 equals 24 divided by 3, or 8. So 4/4 must be 4 times 8. That's another way of doing it. Takes just that bit longer. Train ticket costs £23.50. The price increases by 6%. Felix is £100. Can Felix buy 4 tickets? Well, as soon as you're reading this question, you're asking yourself, well, first thing I've got to do is find 6% of £23.50. You'll probably get at least one method mark for this. It's an older calculator, so I'm going to do 600ths times £23.50 to give me £1.41. It's a price increase, so I'm going to add that £1.41 to the original price. So £23.50 plus £1.41 equals £24.91. Now Felix wants to buy 4 tickets. Can he? Let's work out what the cost of 4 tickets is after the increase. 4 tickets costs 4 times £24.91. Clear that. 4 times 24.91 equals, oops, I forgot the one at the end of that. 4 times 24.91, and there's the cost, £99.64. So yes, the answer is yes. Felix can buy 4. And for that you get 4 marks. 3 more to go. Newspaper headline reads as such: 80% of teenagers think Winston Churchill was a real person. Show the ratio of the number of teenagers who think Winston Churchill was a real person and those who do not is 4 to 1. Well, 80% did to 20% that did not. So the ratio is, the units are the same, 80 to 20. Then we can see that there's a common factor of 20. Write that down, and that shows you, and shows the examiner that you know how we get to 4 to 1 for 1 mark. Hannah says GCSE history students are more likely than other teenagers to know that Winston Churchill was a real person. Design a data collection sheet for Hannah. So let's put the headings in. So we would have a tally here and frequency. So even if we can't work out the questions, might get 1 mark for that. Well, it's basically this. Here's the question: was Churchill a real person? Sorry about my handwriting. And we're going to record the number that answer yes or no for 2 marks. The ratio of history students who think Winston Churchill was a real person and those who do not is 17 to 3. Is Hannah's claim true? Show how you decide. Well, your general teenager, 4 to 1, think that Churchill was real, compared to 17.3. But they're in different forms. This is something to 1. Now there's 2 ways of doing this. First way we could do it is to change 17 to 3 to something to 1. And the way we do that is, well, you divide 3 by 1. So to keep the ratio in the same proportion, we divide the first number. That's one way of doing it. So we would do 17 divided by 3, and we get 5.6 recurring. Another way of doing it, though, is to change this one. 4 to 1 is what to 3. That's the same as 12, 2 or 4 every 3. Either way we do it, we can see that. Probably stick with changing it to something to 1. Is Hannah's claim true? The answer is yes. More. I think. Church was real. The answer on its own, though, without the working, won't get you the 2 marks. And we're getting there. Amir drops different balls from the same height. Measures the height, etc. Calculate and estimate the mean bounce height. Well, the way to do it is this. Let's look, we've got frequency here. 2 of them bounce to 0.4, 3 to 0.6, 7 to 0.8, 4 bounce to 1 meter, 3 bounce to 1.2, and 1 bounce to 1.4. Calculate an estimate for the mean bounce height. Mean bounce height. Why is it called an estimate? Because he's done some rounding here. It's not their exact height. What calculation would we do? Well, we do 2 times 0.4, because 2 bounced 0.4, plus 3 times 0.6, plus 7 times 0.8. Show the calculation you're doing. It's going to be worth some marks, even if the rest goes wrong. Get our calculator. Let's enter all that. 2 times 0.4 plus 3 times 0.6 plus 7 times 0.8 plus 4 times 1.0 plus 3 times 1.2 plus 1 times 1.4, 17.2. But that's halfway there. We're after the mean. So the mean equals 17.2 divided by, how many times did he bounce the ball? 2, add 3, 5, 12, 16, 19, 20 times. So 17.2 divided by 20. To give 0.86 meters for 3 marks. Amir wants to test this hypothesis. Balls bounce higher on concrete than on wood. So he's got the 0.86 meters for the mean for bouncing on wood. Use the data cycle to write a plan for Amir. So we've got the hypothesis. It's done. Now we gather data. What's the plan? Well, it's to drop a ball on concrete. I'm going to misspell concrete here. On concrete. And measure height. And record. Now, next, we come to analyze data. What we're going to do here is we're going to calculate the mean. For concrete. And finally, we compare data. That is, see which had higher mean. And just for that extra flourish to make sure, because we're really after 100% here, and also show new findings on a frequency polygon. If you use one diagram for one set of results, it's good practice, very good practice, to show new results on the same type of diagram. Anyway, that's 3 marks for that. Now, I just had a quick look for this 2011, and to get a grade C or more, big pardon, to get a grade C, because it's a foundation paper, you needed, my memory serves me right, 45 or more out of 54. Well, I hope you did well, and I hope I didn't take too long explaining that.